right, let's do some mean value theorem examples and non-examples. First one is f of x equals x squared on the interval 0, 2. And the question is there a point in the interval 0, 2 where the slope equals the average slope between 0 and 2? In other words, does the mean value theorem apply? And if it does apply, where is that point? So we know, first of all, that x squared is a polynomial and therefore it is continuous and it is differentiable. So yes, the mean value theorem applies. And therefore, there must be some value of c such that f prime of c equals f of 2 minus f of 0 over 2 minus 0. Well, that's 2. There must be some point on that parabola in the interval 0 to 2 where the slope equals 2. And can we find that? Yes, very quickly. F prime of c is 2c. We want that to equal 2. That means it happens at c equals 1. Graph clearly not drawn to scale, which means it is at the point 1, 1. There will be a slope of 2. So that's an example. Let's look at another function. F of x equals the square root of x squared plus 1. Well, we could do a lot of fiddling around, or we could recognize that the square root of absolute value of x squared is the absolute value, because square root of x squared just means make it into a positive. And we know that no, the mean value theorem does not apply because this is not differentiable in the interval that includes x equals 0. And for the purposes of the problem, which I forgot to mention, we're looking at the interval -1 to 1. That's just a vertical shift of absolute value. All right, how about another one? X cubed plus 3 for x less than 1, and x squared plus 1 for x greater than or equal to 1. And the first thing we'll do, first off, we know that this is continuous, except maybe what happens at x equals 1. Well, let's find out. F of x equals 4 and 3. So this is the limits as x approaches from below and the limit as x approaches from above, and therefore this is non-continuous, and therefore the mean value theorem does not apply. All right, sorry about that. It got interrupted by a crowd of students running through the door. So let's go to last example. F of x equals the square root of 1 minus x squared. We are in the interval from -1 to 1. And we want a tangent that is parallel to the secant AB, where A is the point at -1 and B is the point at +1. So thing one, we know it's continuous. We can confirm that. It's the square root of 1 minus x squared, which if we think about it a little bit, we realize it's a circle, which means we also know that it is differentiable. But let's get the derivative anyway, because we're going to need it. Rewriting the function as 1 minus x squared to the 1/2. We get 1/2, 1 minus x squared to the negative 1/2 times negative 2x. Doing a little simplifying, this is negative x over square root of 1 minus x squared. And within the interval negative 1 to 1, it does in fact exist. The open interval negative 1 to 1, it does in fact exist, and therefore we know it is differentiable. And so we can find that f prime of c is equal to, well, f of 1 minus f of negative 1 divided by 1 minus negative 1. F of 1 is 0, and so we discover that, and excuse me, f of negative 1 is also 0. So we discover that this needs a slope of 0, and the only place, going back to our other formula, where that would be equal to 0 is when x is equal to 0. So the tangent parallel to the secant is at f of 0, which means that we've got a tangent line of y minus f of 0 equals, well, that slope is equal to 0 times x minus 0, and we get y equals 1. There is the tangent line that is parallel to that secant, because in fact the secant is horizontal, and therefore the tangent line must be horizontal. All right, so there's some examples of how mean value theorem works. Thanks for watching.